So yeah, it's very important not to exclude everyone. You know, algae are fun. People want to learn about them.
Welcome to Shellphone, the podcast that gives the ocean its very own hotline. Join us as we hear from ocean stewards, discover threats to ocean health, and learn ways we can all answer the ocean's call. This podcast was brought to you in part by the Tampa Bay Estuary Program and Coastal Creative. I'm Harmony Dawson, and joining us this episode is Jenny Gil.
Hi, thank you, Harmony, for the invitation.
Yeah, I'm excited to talk with you today. The first thing that I wanted to do is have you introduce yourself, tell us a little bit about who you are.
Okay, so hi, my name is Jenny Gil, and I'm a phycologist, which most people get confused if I am a psychologist, which I'm not. I study algae. So, being a phycologist means a person, a scientist of algae. And I'm very passionate about algae, and I've been studying algae for over 7 years. I'm also a National Geographic explorer, and I really like education, especially with people with any disability, because I want to teach everyone about algae. And that's me.
Awesome. Yeah, we'll be talking about both of those things later on in the episode. But to get us started, I wanted to get a little bit of background on algae, like what it is, where you can find it, why it's important in our ecosystems. Can you talk about that a little bit?
The first thing is that algae is not a plant, okay? Because it doesn't contain any root, stem, or leaves. And algae can be found what it needs. It is photosynthetic, just like plants. So it needs sunlight, it needs nutrient, and it needs to be in a humid place. So it's not only that we find in the ocean, lakes, river, ponds, we can actually even find algae in the soil. Not necessarily it has to be an aquatic ecosystem for it to be alive. And algae is very important because more than 50% of the oxygen we breathe come from them. Also, they're the first one in the food web, so without them, no other aquatic organism will exist.
Wow, yeah. Usually when I think of algae, I think of it in like an ocean or like water environment, but that's kind of because I work a lot with like marine science. There are like thousands of different types of algae, right?
Yes, and there's also algae that we can see, algae that we can touch, but there's also the microscopic algae, which we need a microscope to be able to see them.
Do you have a favorite microscopic algae?
So hard.
By chance? Yeah.
There's so many that I like. You know, I especially like microalgae when they have flagellas, which is the structure that they use to move. Because I feel when I look under the microscope, sometimes I feel like they're dancing. I'm like, wow. I think one of my favorite ones is Dunanena salina, just because it is so powerful. It's able to turn the water pink due to high carotenoids. And I'll say the second one, being from Puerto Rico, we have a wonderful biobay here. So it has to be the dinoflagellates. And also they have two flagellas, so they move a lot. But that's another reason why.
Nice. I was going to talk about this a little bit later, but since you brought up algae moving with their flagellas, I saw that one thing that you've done is taken a video of that and combine that with music. And that kind of goes with seeing algae through all the different senses, which we'll talk about later. But can you tell me a little bit more about that specific project with the music?
I like to teach people how to learn about algae with all your senses, because I don't like people to feel excluded. So yes, for the sense of hearing, Thanks to a Panamanian band, we synchronize the movement of microalgae to music. Also, for Tosh, I do 3D models of microalgae, which are printed in filaments of algae. And I also add braille, and I have them. There's one here, it's a diatom. And here you can see the braille. And then for food, for taste, microalgae, you can eat them and they're actually very nutritional for you. And sight with amazing microscope picture and smell, there's a lot of, yes, we smell the algae. Most people don't like the smell. That's okay. But most people don't realize that the smell also contributes. Why do we love the ocean smell so much? Where does it come from? That beautiful ocean smell comes from microalgae. When it starts to rain and we start to smell that it's going to rain, where does that come from? It comes from microalgae. So microalgae has a lot to do with scents too. Also, when I go collect microalgae with my net, I cannot see what I collected, but I can smell it. And I know I have a good sample if it smells like fish oil, because fish oil has the amino acid, and the amino acid, where does it come from? It comes from the algae. So it's very important to put our senses, all of our senses, so we can learn.
Yeah, that's really interesting about how you can smell more versus less algae in the water for like what would be a good sample. I also didn't know that your sculptures had braille on them. Does it read like the name of whatever the organism is?
Yes, it reads the name of the organism.
Cool. And you're working on creating more sculptures right now. I believe you mentioned the last time we talked.
Yes, I am currently doing an artistic residency with my boyfriend, and now we're doing sculptures of ceramics. And we have picked, there's 2 microalgae and there's 1 microorganism, a bacteria. So we're gonna do sculptures which people can touch, and we're also gonna implement our senses during the exhibit. So the final objective will be that this will be an exhibit that people can go and learn about microorganisms from Puerto Rico.
I've seen a lot more museums start doing like interactive exhibits. I think it's great that interactive exhibits also bring more possibilities for education and accessible education.
Yes, and it's not only made for people with disability, it's made for everyone, because you know what? You learn more when all your senses are activated when you're learning.
So this is kind of switching gears a little bit, but I wanted to talk about a quote that's one of the first things you see on your website, which says, "I celebrate my accent. Even though being Hispanic in the sciences can be hard, I'm proud of my heritage." I'd love to hear more about what your journey into the field of science has been like from that perspective and how you've incorporated that into your work.
Yes, I actually, now that more time has passed, I'm kind of conflicted with that quote that I put there. Because even though, yeah, sometimes it could be hard, but actually sometimes it has been an advantage, because I've been able to collaborate with so much scientists in Latin America because I speak Spanish, right? And I'm able to communicate with them better. So I actually realized what I thought was like a harder issue for me, like language, papers being in English. Now I see it with another eye. I'm like, well, actually, it could be an advantage because it opens the horizon for me to do a lot of collaboration with scientists that speak my own language and have similar culture. But I also like to do collaboration with other countries that I don't speak language, like Japan. I had the wonderful opportunity to do research in Japan, and it was amazing. So I think more and more that time passes, I realize that what you think may be hard or maybe a disadvantage could actually be your advantage, right? And we have to be proud always where we come from. And if you are not a native language speaker in English, that's okay. You start practicing, you start learning, and every accent is beautiful. So we just have to embrace that.
Yeah, that's a great message to hear about how your perspective on that has changed and where you're at now. What other kinds of places have you been able to travel to and work in, and what different environments have you been able to connect with?
Yes, I recently was able to do a project in Puerto Rico, but also do it in the Caribbean islands of San Andres and Providencia, which I had a great time there, right? And culturally, I saw a lot of connection with Puerto Rico, which was wonderful. I've also lived in Panama, and Panama had always been a huge dream of mine because Panama, you have the Pacific and the Atlantic, the Caribbean, so close together. So you can be one day collecting in the Pacific and the other day collecting, like the same day collecting in the Caribbean, which is amazing for me. And I've also been able to work in Europe, in the US, but there's so many other places I'm interested in working on. But I definitely love working in islands, right? There's something about, maybe it's because I'm from an island, but I really enjoy working in a place that is an island, that is surrounded by water. That's where I feel more comfortable and more inspired.
What are some unique pieces of the environment that you find in islands, whether that's certain species or certain geographical things, or even differences in the algae that you see?
Yes, well, first of all, being an island, islands are more vulnerable to climate change, to big algae blooms. Now before I was talking about microscopic algae, but now going to macroalgae, the huge issue that we're having of sargassum in the Caribbean, which is something new that happened in 2011. So actually being able to help people or find solutions to a huge problem it makes me feel very good. It makes me feel like, okay, I'm doing science, but I'm also working with the community.
That has to do with your PhD that you're working on, right?
Yes. So I also get another Nat Geo grant in where different Nat Geo explorers, we joined to tackle the problem of sargassum. And we did educational workshops, and we also did co-creation workshops to co-create an equipment to be able either to clean the sargassum or to make something from the sargassum. So I taught people how to make ink, how to make paper, how to make soaps, how to make fertilizer with sargassum, which most of these people I teach to get so much sargassum, they don't know what to do with it, right? But sargassum has so much potential, and we have to give the tools to the people affected, right? We have to give the tools to the community so they're able to profit from this, hopefully.
What is the issue of sargassum? Is it just that there's so much in this area that you're looking at, or?
So sargassum is not like a new algae that has come to the Caribbean. It's not an invasive algae. No, the algae has been forever. Okay, so usually it has lived near the Triangle of Bermudas. But what's happening now, which there's a lot of theories of why is this happening, is that now because this sargassum is an algae that doesn't need a substrate to grow. It grows by floating and it moves with the wave and the currents. So now it's taking the current of starting in Africa, going to Brazil, going up to the Caribbean, then the Gulf of Mexico, and then finally in Florida. And the big issue is the high amount of sargassum that we're getting, right? Living in Puerto Rico as a young age, I knew about sargassum, but I would never see so much sargassum. And the huge issue is that when it reaches the coast, it starts to degrade and it produces sulfide. Also, it affects a lot of the aquatic organisms. When the algae reach the coast, it looks like a, I forgot the word in English, like a rock, right? So it looks like a rock, and then it doesn't let any light or oxygen in, and the organisms start to die. So they're a big algae bloom. Also, fishermen have a lot of issues. I've been on boats that the motor stopped working. You know why? Because algae get tangled in the motor. So it also affects fishermen. It affects tourism so much. Tourists no longer want to go into the ocean with, with this algae and how it smells. It affects every small business, especially restaurants that are near the coast, because customers no longer want to go there and eat and smell the algae.
Okay, thank you for explaining that. That was a great explanation. That reminded me of something that I read about you collecting samples, water samples on a boat, and then having like a portable microscope with you, so you were actually able to show the people on the boat what you were collecting samples for. And that was something that they hadn't really experienced from other scientists who had used their boat before.
Yes, sometimes, but not all the time. I bring a microscope with me. And that moment was very beautiful because I had my microscope with me. So I was able to showcase everyone that's in the boat. Because when you go collect sample, it's not only you go and collect samples. Well, in the case of how I collect my samples, I need captain of a boat to drive me there, So I thought, oh my gosh, I have to show everyone, again, I have to show everyone this algae that I just found. So I showed to the captain and his face like totally changed. He was so excited because he told me, oh, I have brought so many people, like so many scientists to collect, and nobody had shown me what they collect. Nobody has stopped and explained to me what they're doing. So yeah, it's very important not to exclude everyone. Algae are fun. People want to learn about them. It's all about sharing your knowledge and not like gatekeeping it. Right? Science may want to gatekeep it or only do scientific papers, but things like this, like the podcast or other educational outreach projects are so important because, the way that we're going to change the world is with everyone's help. We need everyone's help to change the world. So this is why we need to educate everyone. And, when you start to love something, when you start to really care about the environment and love the environment, is when you know about it. When somebody teaches you about it, if you don't know, you don't care. So you first need to learn about it so you're able to care and love, in this case, the environment, the algae.
Yeah, that is very true. I've heard that from many guests that we've had on the podcast. And of course, like you mentioned, part of the reason why we do this. So I'm glad that you were able to share that experience with the captain of the boat and in other ways as well.
Yeah, even one time I remember another one. I mean, there's been so many occasions. One time I wanted to collect in the port. I was in, I think, yeah, it was Santo Domingo, and I throw my net, and then police came, and I'm like, oh my god, police coming. And he's like, oh, what are you doing? And I'm like, oh, I'm just collecting some samples. And then, you know what finally happened? Like, I show her what I was collecting. And then she's like, can I throw the net? And I'm, of course. So I have like a picture and a video of the police throwing the algae net to collect algae. Right? So everyone, like, if you really take your time and explain what you're doing, well, not everyone, but I've been very lucky that most people really want to participate in everything that I'm doing, and they want to learn more.
I also wanted to mention the idea that microscopic algae is invisible in a lot of ways, and how all of these different projects are helping to make it more visible. And I've seen that you've spoken about also sometimes feeling invisible in science. What does that kind of connection mean to you? And does it have anything to do with why you're interested in studying these kinds of things? Or was that just something that happened by coincidence?
Yes, I think I've always been very curious about the invisible world. And maybe it is because I can somehow relate, or all of us can relate somehow. Like any moment, maybe you have felt invisible for many reasons, right? And it was that sense of invisibility that inspired me to look at this invisible microscopic world. So again, it's taking something that could be negative or difficult and turn it to something positive.
So next, I'd like to talk about some of the different places that you've worked with, like National Geographic, NASA even. Working with those kinds of places is something that so many people dream of. Like I used to look at Nat Geo magazines and think that like that's where I want to be, writing those stories, taking those photos, doing things like that. What did you do while you were working with those places? I'm especially curious about NASA. I think you mentioned that it did have a connection to algae as well, but maybe not an obvious one. So if you could talk a little bit about those, that'd be great.
Yes, for me, I also grew up reading Nat Geo magazines. My little secret is like I actually don't like to read a lot, but the magazines, I could read them, right? Because I see big pictures and small articles I can read really fast, and I can learn so much from them. So it's also had been a huge dream of mine to be able to be in the community of Nat Geo as a Nat Geo explorer. So I encourage everyone, and I encourage you, Harmony, too. So Nat Geo has different grants which you can apply to. So you can go to their websites and apply to their grants. I got a special one, which is a Fulbright Nat Geo fellowship. So you can also apply for a Fulbright if you are a U.S. citizen. But if you're not a U.S. citizen, the Nat Geo grants are open for anywhere around the world. And yeah, it's been such a dream come true. I've been able to be a speaker in different countries around the world. Thank you to National Geographic Learning that always sponsors me. It had opened me the door to other explorers and other people doing amazing work. And with the NASA one, how I ended up doing that is, well, I never actually I'm going to work with NASA. I never dream about that. But actually my bachelor, I had a NASA grant, because actually during my bachelor, I was doing something totally different, that it wasn't algae. right? In my first year, I was a physics major. That didn't work out. And then I was working in a nanotechnology lab, which I got a grant from NASA. And then NASA happened again during a period of my PhD because I started thinking about algae, and then I started reading that algae has gone to the International Space Station, and the power that algae have for space exploration, totally blew my mind. I was like, wow, algae can go to space. So there I was working in a project with different microalgae, one of them being Dunanea salina, and I was studying their potential to clean the urine of the astronauts. Because actually, algae can help astronauts in their breathing. It can help them also for food because they can eat it. And remember that when you're in space, you want to bring as little as you can. So all your waste is recycled. But guess who can help recycle that? The algae can do that. Also, you can use algae as material for the 3D printers that are already there. So algae has a lot of potential to be used not only in the International Space Station, but also if we plan to go to Mars, right? If we go to Mars, we have to grow our food. And just growing algae has so many nutrients that we need that is very efficient way for food. And then I was also involved with NASA because I was a NASA intern. I was working with yeast, and that paper actually is hopefully will publish soon. But I was working with yeast, and you will be saying, why yeast, right? Yeast has also gone to space because they're studying the yeast, because the yeast genes and our genes is very similar. So they want to see how radiation affects the yeast, and it give us clues about how the radiation is going to affect us. But they're also very interested in the yeast potential for food. You're in space, you want some bread, yeast, right? So, well, the beer thing, I don't think they're doing the beer in space. No, no, no. But for yeast for food too, for the astronauts. So the microscopic organisms are key during space exploration, and I'll say that they're key too in food, because the food that they eat right now is very synthetic, and it's better that they get the right nutrients that they need during space, because the synthetic food don't have all the nutrients that they need. But if they have algae or if they have yeast that are full of carotenoids, it will really help the astronauts.
Awesome. That's super interesting to hear about. I know that you've made a lot of food using algae here on Earth. What are some of the different types of food that you can make using algae?
Yes. Well, the Japanese are way better. If you go to Japan, you're going to get to explore all the algae. You're going to taste so many algae. It's amazing. But simple things like a spirulina smoothie, right? Or in spirulina, you can add it to your pancakes. You can add it when you're doing your cookies. Also, there is a very famous salad in Japan called hijiki salad, which is made of sargassum. But the sargassum that we get in our coast, we should measure the heavy metals before eating them. Yeah, watch out, because algae actually absorb heavy metals. So we have to be careful of, what type of algae we eat. Where is that algae coming from? That algae comes from dirty water. Maybe it's not a good idea to eat it, right? So also get very informed of where that algae is. But yes, Harmony, I don't do enough plates. I've eaten sushi, but I'm very bad at making sushi. I'm not a good cook. I like to bake things, cakes and cookies and simple things like smoothies.
Is the thing that you mentioned about algae absorbing metals and maybe absorbing things that we shouldn't be consuming something that you've personally studied, or is that research that you've read about?
It's research I've read about, but I've also sort of studied it because I did take samples when I was doing my workshops. All of the algae we use, I sent it to 2 different labs to make sure it did not have arsenic. I was like, well, I need to make sure that this algae that I'm using in workshop doesn't have the arsenic. But yes, there's a lot of published data, especially more from Mexico, that they have found high concentration of arsenic in sargassum, right? But maybe also that's another power that the sargassum have, one of bioremediation, because algae is able to absorb heavy metal in contaminated environments.
That's a great point. It seems like there are a lot of things of where it could seem challenging or negative, like we've talked about, but this is another one where there's also a positive side to it. Going back to how you've gotten those grants and different opportunities, internships and things like that, do you have any advice for people who are trying to do the same?
Yes, I think my best advice, what I've always said, most of the things I get is because I applied 2 times or 3 times, okay? Sometimes I apply for one thing and I don't get, and then I try the next year, and then I try the next year. So if it's something that you really want, you just keep improving yourself and keep applying. And also don't tell yourself, oh, I'm not going to apply to that. That's way too competitive. I'm not good enough or something, you think that. You shouldn't think that. You should just apply because you don't know. And the worst thing that they can tell you is no. And if they tell you no and you really want that opportunity, you keep on trying. You keep on trying to improve your proposal.
There's another project that you mentioned when we initially talked with each other that had to do with looking at the effects of sunblock on algae and corals.
Yes.
What does ecotoxicology mean, and what did doing that research on this topic look like for you?
That I did during my master's degree. So ecotoxicology means to study an organism, or it could be either, it could be a person. It's just studying an organism and how toxics affects them. So that was my very first time actually working with algae because, like I mentioned before, my bachelor was in something else. And it was during my master I truly was able to focus on algae. And I am a sunblock freak. I would never go outside without sunblock because I've gotten burned so bad that had to go to the hospital. So definitely it's not that don't wear sunblock. You should wear sunblock, just be very aware of the chemicals it has. And I was interested to know how nanoparticles that are being used in sunblock affect the microscopic algae. And yeah, most people don't know this, but actually corals and microalgae have a symbiotic relationship. And what it means when we see coral bleaching, most people say, oh, the coral is dead. Actually, what's not longer there is the algae. The coral still has the potential to revive, but because the little microalgae, which are called zooxanthella, are no longer inside of the corals because they were all very stressed out. They're no longer in the coral, and that's when coral bleaching starts to happen and the coral starts to die. But sunscreen can really affect, in the study I did, the microalgae. Due to their small size, nanoparticles are actually able to break down through the cell wall and kill them or potentially make them weaker, right? Or make them so uncomfortable they're stressed out. So it's very important to know the type of sunblock that we have. And I think in most paper, maybe now more people are more aware about the dangers of sunscreen. I think in some states, I think Hawaii has banned sunscreen that is not coral reef safe. But you need to be aware because some coral reef safe products may say that they're coral reef, but then you look in the bag and you see nanoparticles. And that's where it gets complicated. You really don't want to see nanoparticles in your sunscreen when you apply them. I also encourage people to wear long sleeve. Cover yourself a lot if you're going to be exposed to the sun for a long time, because also, cancer is real, right? Skin cancer. So it's not that you don't wear sunscreen. It's just you wear the right sunscreen or the right clothing for you to go expose yourself into the sun.
Yeah, it's not something that's always easy to figure out just by looking at all the sunscreens on the shelves, but I think there are a lot more resources coming out that give you easier to understand information on what's in each of the different options. So it's getting a little easier to navigate, I feel like.
And I think helping with the policy, like what Hawaii did, right? Like you cannot go in unless you have your reef safe sunscreen. Having some type of law or policy, I think it makes it better for the customers and for the environment.
Yeah, that's very true. With the mention of nanoparticles and all of that, I wanted to ask, how big are microalgae compared to like things that we could see? If there's any way that you could quantify it just for people to think about it. I know they're very, very small,
yeah,
but is there any kind of way that you explain it?
Yeah, I don't know. There is a quote that compares like, imagine a baseball field and if there is a grain of sand there, but I just don't remember the code exactly, Harmony, so I don't want to say something that I'm not very sure of. But yes, it is extremely, extremely small, so small, like you can see the hair, right? But the algae you cannot even see. And like a strain of hair is already very small, or a piece of sand. You see it very small, but you can see it, right? But microscopic algae, you cannot even see it if you take water and you're like, ooh, there's algae. No, you cannot see them. You need a microscope to be able to see them.
Going back to the point about accessible education for everyone, you mentioned that like your exhibits and other programs aren't just for people with disabilities or certain sensory needs. I'd like to talk a little bit more about why programs like that are important, especially for people who would be left out of traditional education.
I think what inspired me the most is because I've been exposed to special needs students through my mom. My mom is a special needs teacher. Also, I'm a Special Olympics volunteer, and I have a disability myself, which is dyslexia. And I've felt excluded in their learning process. And I'm a person that really likes to learn. It just takes me longer. So all of that inspired me to be more inclusive. And I think it's very important not to exclude anyone because it takes them longer to learn because they learn different than some people. That's okay. The important thing is that you learn about it and that you start knowing and educating yourself so you can love and protect the environment.
Have you noticed a lot of changes and improvements being made in scientific fields and education in general over the years?
I think there's some things like apps that you can use so they can read the paper so you can have an audio if it's really hard for you to read. But I think we have to do way more of what we're doing. We have to include more diversity in the sciences, more than we're doing. But with the technology, if used positive, I think the technology has so much potential to be able to be used to teach so many people. So I think the technology is key. All this AI coming up, I know some people are scared, but if used in a positive manner, I think it's gonna be great, especially for people with disability or people that takes them longer to learn.
Great. So those were all of the questions and topics that I wanted to get to, but if there's anything else that you want to talk about, now's the time when you can do that. If not, that's okay too.
Yeah, I think, Harmony, we cover a lot because I have a lot of projects. But yes, the project of the senses, learning about microalgae through your senses, now it has every year it transforms. This project never dies. Now I have included macroalgae, so we learn about microscopic algae and macroalgae through our senses. I've been able to present this activity in Panama, but also in Spain in an organization called ONCE. And finally, this Saturday, I am going to get to present it in Puerto Rico with the Blind Foundation here in Puerto Rico, which I am so excited about. And I also want to do this activity. I want to publish it in a scientific paper so more people can do this activity in their community with their students.
Yeah, that is really exciting. And it'll be interesting to see how it keeps evolving as you continue on. Well, thank you so much for talking with me today.
Thank you, Harmony. I had a good time. I hope you can visit Puerto Rico soon.
Yeah, that would be great. I definitely need to expand my experiences a little bit more outside of where I've been.
You can also apply for a Nat Geo grant.
Yeah.
Also, next week I'm in DC at the Smithsonian teaching people how to do algae ink.
Oh, really?
Yes. So I'm excited, but I'm nervous because I'm trying new inks. Because I really want to dye clothing. That's the new thing I want to do.
Yeah.
But for that, I need to treat the fabric.
I saw on your Instagram you were posting about testing out different inks.
So anytime you are interested in making your own algae ink, I don't know what type of algae you get there. Yeah, you can do it with any algae.
Yeah. What do you use algae ink for a lot? Like I saw I think some photos of like kids painting with.
When I was doing ink, I thought like people were not gonna get very into it, but people are getting very into the ink. I think because it's so easy to make with things that you have in your home. And yes, especially kids have a lot of fun painting with the sargassum, and without they knowing, they're also learning about the algae, right? So it's like, okay, you're painting, but do you know where this painting comes from? And that's how you get people excited and want and learn about the algae. And this time around, I'm gonna do it with high school students, which they make me nervous more than older. Like older, it's okay, young, okay, but high school students, I'm like, oh. So let's see how they enjoy doing the ink. They wanted a project or a workshop that mixes art and science, and that's why they call me.
That's exciting. I think that's something that a lot of people are, I don't know if I'm just hearing more about it or if more people are getting interested in it, but we've spoken to like a few people, and I know of quite a few people who are doing that work of blending art and science together, mostly through like creating something to show to people. But I've also heard some about like workshops of getting people actually involved in doing that process, which kind of connects to the point that we mentioned earlier of how learning about things and doing things like hands-on helps people like care more about what they're learning about. So it's exciting to see.
Yes, and art and science always connect so much.
Yeah.
And today I was interviewing, they found a new bacteria here in Puerto Rico. I was interviewing the scientist.
Oh, really?
Because that's one of the bacteria we're doing in ceramics.
Oh, it was like recently discovered?
Yeah, and last year it was published, the paper.
So you were interviewing her to learn more, to like incorporate that into the ceramics project?
Oh yeah, and it's helping us like a lot because there's some things that the paper didn't say. Like she told us, like when I told her, how do you think this, because she does bioinformatics. So what that means, she doesn't actually sees the bacteria. She doesn't know how it looks like. She's not cultivating it in a lab. She's actually just looking at the genome. So, right, with the computer, but the genome can tell you a lot of characteristics of this bacteria. And one of the characteristics that she didn't put in the paper, but she told us about, is that it contains one flagella. And we're like, oh, it's amazing. Because we were going to put up many flagellas, and now we know there's one, right? So asking questions to the scientists and to represent the sculpture better, if we talk to the scientists, really helped us. And it's amazing how science is growing so much that you no longer have to do it like I've done it all my life. Like, oh, let me look at under the microscope. Let me isolate it. Now with bioinformatics, it tells you a lot about the organism.
Wow, that's really cool. I didn't know that one of the sculptures that you were making was of something that you haven't actually seen and more something that you were imagining or using the information that you do have that's not like how it actually looks to come up with how it might look.
Yeah, like it tells you genes, like it's able to clean explosive and heavy metals, but they all find this out through the gene information, the genome.
What's that? What is it called?
Oh, I should know, but okay, let me see if I can pronounce. BKE bacterium resilience.
Okay, cool. Well, I'll be excited to see how that turns out.
Yes, Harmony, so nice to meet you, and I'm happy for what you are doing.
Yeah, of course. Thanks for talking with me.
Okay, ciao, Harmony.
Bye.
Bye.
Thanks for tuning into Shellphone. To learn more about our projects, suggest a guest, or donate to the show, visit our website at breachthesurface.org or social media at breachthesurface and at Shellphone Podcast. To learn more about Jenny's work, visit her website at jennygil.com or her Instagram at jennyalgae.